Episode 79, titled Flow Diagrams, Narrating Traffic Paths for Security and Ops, the focus is on flow diagrams as storyboards for packets and controls, because a good flow diagram turns a vague architecture into a sequence you can reason about and test. Network diagrams show where things are and how they connect, but flow diagrams explain what actually happens when a user does something, like logging in, calling an internal application programming interface, or retrieving data. The exam tests this skill because many security and availability failures occur in the gaps between components, where assumptions about traffic paths and control points are wrong. A flow diagram forces you to name entry points, decision points, and choke points, and it reveals where identity checks happen and where logs must be captured. It also helps operations teams because it clarifies which systems are on the critical path and therefore which systems must be monitored and which failures will cause outages. When you can narrate a flow clearly, you can identify missing controls, missing dependencies, and hidden single points that a static topology view can hide. Flow diagrams are therefore a bridge between design intent and operational reality. This episode builds a consistent approach to flow narration so you can use it for security validation and for incident response planning. Before we continue, a quick note: this audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Flows describe sequence, entry points, decisions, and choke points, which means they show the order in which traffic moves and where it is allowed or denied. Entry points are where traffic first enters a trust zone, such as a remote access gateway, an application gateway, or a load balancer. Decision points are where policy is applied, such as firewall rules, access control lists, identity checks, or routing decisions that steer traffic to different backends. Choke points are where many flows converge, such as a shared firewall, a shared identity provider, or a shared domain name system resolver, and they matter because failures there have broad impact. Sequence matters because the same components can exist in a design but be engaged in different orders depending on the path. And order determines what control is applied before what risk is exposed. The exam expects you to show that you can reason step by step rather than treat connectivity as a single blob. When you explain a flow, you are also implicitly defining what should be logged and where troubleshooting should begin when something fails. Sequence also reveals performance constraints because each hop adds latency and each decision point can add processing overhead. A flow diagram is therefore an engineering narrative that makes the invisible visible. Identity steps should be included explicitly because authentication and authorization checks are often the true gatekeepers, even when networks are segmented correctly. Authentication is the act of proving identity, such as proving a user is who they claim to be, while authorization is the act of deciding what that identity is allowed to do. In modern systems, these steps can occur at multiple points, such as at a remote access gateway, at an application gateway, and within the application itself. Leaving identity steps out of a flow diagram is dangerous because it can make a design appear secure through network boundaries, while the actual access decision is made elsewhere. Identity steps also influence failure behavior because if an identity provider is down, users cannot log in, even if the network path is otherwise healthy. The exam often tests this by describing systems where connectivity exists but access fails, pointing to identity as the missing element in the flow. Including identity checks also clarifies where multi-factor authentication is required and where tokens are issued or validated. When you include identity explicitly, you can evaluate whether controls align with risk and whether logs exist to prove access decisions. Labeling trust boundaries and inspection points along the path is a key directive because flows are most valuable when they show where the security posture changes. A trust boundary is where traffic crosses from a less trusted zone to a more trusted zone, such as from the internet into a demilitarized zone, from a user network into a server network, or from a development environment into a production environment. Inspection points are where traffic is evaluated or filtered, such as at firewalls, gateways, web application firewalls, or intrusion detection sensors. Labeling these points makes it clear where policy enforcement occurs and where there may be gaps, such as traffic that bypasses inspection due to an alternate route. The exam expects you to recognize that security is applied at boundaries and that boundaries must be explicit in your reasoning. Labeling also helps you identify where encryption terminates and where traffic can be inspected, which affects both security and privacy considerations. When you label the boundary, you can ask what controls apply there, what logs are produced, and what failure modes exist. Flows without labeled boundaries often look complete while hiding the most important security questions. Dependencies like domain name system, time, and directory services should be captured because they are often required for a flow to succeed, even though they are not the primary application components. Domain name system is needed to resolve names into addresses, and if resolution fails, applications fail even if routing is correct. Time services matter because authentication tokens, certificate validation, and log correlation depend on accurate time, and time drift can cause seemingly random authentication failures. Directory services matter because enterprise authentication and authorization often rely on a directory for identity, group membership, and policy decisions. The exam tests this because dependency failures are common, and flow diagrams that omit dependencies produce false confidence. Capturing dependencies also helps with redundancy planning because you can see which supporting services must be highly available to meet uptime requirements. It also helps with incident response, because if users cannot log in, you know to check identity and domain name system rather than only checking application servers. Dependencies can also become choke points, so including them in flows makes risk visible. When you include dependencies, the flow becomes a full story of what must work, not a partial story of what you wish were sufficient. A scenario mapping user login through a gateway to an application and database is a classic flow because it touches identity, trust boundaries, and multiple tiers. The user begins outside the internal network, initiates access through a gateway that terminates the external connection, and authenticates using an enterprise identity provider. Once authenticated, the gateway authorizes access to the application entry point, which may be a load balancer or an application gateway that enforces additional policy. The user's request reaches the application tier, which may validate the user's token again and apply authorization rules based on role or group membership. The application then queries the database, crossing another trust boundary where database access rules and segmentation controls apply. Throughout the flow, domain name system resolution is required for the user to reach the gateway and for the application to reach its backends, and time synchronization is required for token validation and logging. This flow reveals choke points such as the gateway, the identity provider, and the database tier, and it reveals inspection points where traffic is filtered and logged. The exam often expects you to visualize this kind of sequence because it is the backbone of many security questions about remote access and least privilege. When you can narrate this flow, you can then ask whether each boundary has the right controls and whether logs exist to reconstruct the path. Forgetting the return path is a common pitfall because asymmetric routing can break stateful inspection and cause confusing failures even when the forward path appears correct. Many security devices, such as stateful firewalls, expect to see both directions of a session so they can track state and enforce policy consistently. If the return path takes a different route that bypasses the original device, the firewall may drop return traffic or may treat it as a new session, causing timeouts and partial connectivity. Asymmetric routing can also confuse monitoring because logs may show only one direction, making it hard to reconstruct what happened. The exam tests this by describing scenarios where traffic appears to leave but responses do not return, or where certain flows fail only in one direction. A correct flow diagram includes both forward and return path, showing which devices see each direction and where state is maintained. It also shows where network address translation occurs, because translation often influences return routing and state tracking. When you include the return path, you reveal whether routing symmetry is required and whether the design supports it. This prevents the classic mistake of drawing a one-way story and assuming the other direction is identical. Omitting error paths like failover and retries is another pitfall because real systems rarely follow the happy path all the time, and the exam often tests resilience through alternative flows. Failover paths show what happens when a primary component is down, such as a gateway failing over to a standby, traffic shifting to a different region, or a database failing over to a replica. Retry behavior shows what happens when a request fails, such as clients retrying connections, load balancers reattempting backends, or applications queuing work for later. These behaviors can change load patterns and can change which control points are exercised, sometimes creating unexpected bottlenecks. The exam expects you to recognize that a design that works on the happy path can fail during failover if the alternative path is not tested or if policies are missing. Error paths also matter for security because a failover path may bypass inspection or logging if it is not designed carefully. Including error paths in your thinking helps you place monitoring and logging where it will still capture events during outages. When you remember to include error paths, you are designing for real operations rather than for diagrams that only work when nothing is wrong. Keeping flows simple is a practical quick win because overly complex flow diagrams become unreadable and therefore unused. One main path per diagram is a helpful rule because it forces you to focus on one user story and one set of controls at a time. If you need to show a failover path, you can include it as a clearly marked alternate path, but you still keep the core narrative focused. Simplicity also supports stakeholder review because security teams and operations teams can validate one path thoroughly rather than skimming a crowded diagram and missing key points. The exam rewards clarity because scenario questions are essentially asking you to reason through one path and identify missing controls or dependencies. A simple flow diagram also makes it easier to maintain because changes in one component can be updated without rewriting an entire system map. This aligns with how effective runbooks are written, focusing on one procedure rather than one giant document. When flow diagrams are simple, they can be used during incidents as quick references. Simplicity is therefore an operational advantage, not a reduction in rigor. Operationally, Flows are valuable for validating, monitoring, and logging placement because they identify where evidence must exist to support detection and investigation. If you know the flow's choke points and inspection points, you can confirm that logs are collected there and that alerts are configured for abnormal conditions. You can also validate that correlation is possible by ensuring consistent time sources and consistent identifiers across logs, such as user identifiers and session identifiers. Flows help you detect gaps where traffic crosses a boundary without logging, which is often a compliance and security concern. They also help validate that monitoring covers both the forward and return path, so you can detect asymmetric routing issues and incomplete visibility. The exam expects you to think about logging and monitoring as part of design, not as an afterthought, and flows make that thinking concrete. Using flows for monitoring validation also improves operational readiness because it tells teams where to look first when a symptom appears. If login fails, you check identity and gateway logs. If application calls fail, you check the gateway, load balancer, and application logs in sequence. When monitoring is aligned to flows, incident response becomes faster and less chaotic. A useful memory anchor is who starts, where goes, what checks, where ends, because it captures the essential questions every flow diagram should answer. Who starts identifies the actor, such as a remote user, a service account, or an automated system. Where goes identifies the sequence of components and networks traversed, including gateways and internal tiers. What checks identifies the authentication, authorization, inspection, and policy enforcement points that decide whether traffic is allowed. Where ends identifies the target resource, such as an internal application programming interface, a database, or a storage service, and clarifies the final trust zone reached. This anchor is valuable on the exam because many questions are essentially asking you to reconstruct a flow from a description and identify missing checks or mislocated controls. It also helps you remember to include dependencies like domain name system and directory services because they often appear as what checks or where goes steps. When you apply this anchor, your flow narration becomes structured and complete. It prevents you from skipping the identity and boundary elements that matter most. To practice, imagine narrating a flow for a remote user accessing an internal application programming interface, and build it as a sequence with boundaries and checks. The remote user first reaches a controlled entry point, such as a remote access gateway, which terminates the external connection and initiates authentication against an identity provider. After authentication, the gateway authorizes the user for the specific internal application programming interface access, applying policy that limits reachable destinations. The user's request is forwarded into an internal trust zone, often through a firewall or inspection point that logs the connection and enforces allowed ports and destinations. Domain name system resolution may be required to reach the internal application programming interface name, and the gateway and internal systems must have correct time to validate tokens. The application programming interface endpoint validates the user's token and applies authorization to the requested action. Then it may call back-end services, such as a database, through another segmented boundary. The return path carries responses back through the same gateway and inspection points, so stateful devices see both directions, and logs capture the full session. This narration highlights identity checks, trust boundaries, and dependencies, which is what the exam expects you to surface. When you can tell this story cleanly, you can also decide where to place logs and how to detect anomalies. A mini review of the flow elements is that a good flow shows sequence, entry points, decision points, choke points, identity checks, trust boundaries, inspection points, and supporting dependencies, and it also accounts for return paths and important error paths. Sequence is the order of steps. Entry points are where the flow begins inside a trust boundary, and decision points are where policy determines what is allowed. Choke points are shared components that many flows depend on, and they often become high-impact failure domains. Identity checks include authentication and authorization, and they should be placed where they actually occur, not where you wish they occurred. Trust boundaries and inspection points show where security posture changes and where visibility must exist. Dependencies like domain name system, time, and directory services are required for success and must be included. Return path is necessary for stateful behavior, and error paths matter for failover and retry behavior. This list is the checklist that keeps your flow diagrams complete and operationally useful. When you can recite these elements once and then apply them, you have the skill the exam is testing. To close episode 79, titled Flow Diagrams, Narrating Traffic Paths for Security and Ops, the essential point is that flow diagrams turn architecture into a packet story that reveals where control is applied and where failures will hurt most. Flows show sequence, entry points, decision points, and choke points, and they must include identity steps such as authentication and authorization to reflect real access control. Labeling trust boundaries and inspection points makes security posture visible, and capturing dependencies like domain name system, time, and directory services prevents false confidence and reveals hidden single points. Scenarios like user login through a gateway to an application and database demonstrate how flows clarify both security and operations by showing where policies and logs must exist. The common mistakes are forgetting return paths, which can cause asymmetric routing failures, and omitting error paths like failover and retries, which can bypass controls during outages. Keeping flows simple, one main path per diagram, makes them usable and maintainable, and using flows to validate monitoring and logging placement improves operational readiness. The memory anchor of who starts, where goes, what checks, and where ends provides a simple method for constructing and evaluating flows. Your rehearsal assignment is a packet story rehearsal where you narrate one critical business flow end to end, including return path and one failover branch, because that rehearsal is how you demonstrate flow reasoning the way the exam expects. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.